Mango Co. Let's go ahead. We're going to look at actually DeltaMath today, but don't start on it yet because I want to. Don't get started on it till. Oh yeah, you'll have a lot of time to work on it. You have two sections that you're going to be doing in DeltaMath. You'll have most of the period to work on it. You're going to be doing horizontal, asymptotes, and vertical. They're like what we did yesterday, except they're a little bit harder problems. So I'm going to walk you through some of these. Let's start with. All right, we'll start with this one. All right, so we're going to be doing horizontal asymptotes. Some of the problems are written in a little bit different form. This is written in what we call factored form, where it's already factored out. If we're going to find the horizontal asymptotes, we need to look at the biggest powers, right? The biggest powers on top and bottom, compare those. So this one, it's not written in the right form. So what we're actually going to do first is just like when we did the end behavior, where we wanted to find like the leading term, the biggest term, we're going to do that. We're just going to multiply all the first terms, because that's going to give us our leading term. That would be 2 times 3, x would be 6x, times 3 would be 18x squared. And on the bottom, we have 3 times x, is 3x squared. It doesn't really matter what the rest of that is, because they're not going to be the biggest terms. It really doesn't matter. We'll use these to determine our asymptote. So then we decide on our rule for the same power. So that means it's going to be the ratio of the leading coefficients. So that would be 6. We also, so we're going to type that in. We're going to select if there's 1, if there's none, whatever. And we have to type it in as an equation. So for a horizontal asymptote at 6, is that an x or a y? Yeah, it's going to be a y. If you think about it, it's horizontal. It goes through a y value. So that's how you pronounce it, y. So we're just going to type in y equals 6. All right. Next one. This one does not have, you don't have to multiply it out. Most of them you don't, but some of them you do. So you're just going to look at it. Same powers. Ratio of leading coefficient, so y equals 6. So let's see if it's 1. And don't get started yet. There are some. All right, this one, we've got the powers. First power on top, second power on the bottom. So what's the asymptote? What happens if it's the bigger power on the bottom? 0, right? Y equals 0. So one horizontal asymptote, y equals 0. So these are going to be the easy ones. You're just going to be doing the rules. The exception is if you have to multiply it out first. Those are going to be easy rule ones. Definitely pay attention to this next part though, because these are going to be a little bit more challenging problems. The vertical asymptotes. Some of them won't be bad, like this one. We're trying to find the vertical asymptotes. We're always going to set the denominator equal to 0. So let's do that and solve it. We get 3x is negative 6. Divided by 3, we get x is negative 2. So that's going to be our answer. We would say one vertical asymptote, and we would say x equals negative 2. Now the only thing is we have to also check and make sure it's not a 0 in the numerator. So what we're going to do is take this and plug it into the top. We get 5 times negative 2 minus 9. That's like negative 19. It's not 0, right? Not 0. So that means this is okay. This is good. It's the correct answer. If we had gotten 0, then we would eliminate that. What ends up happening is there's a hole in the graph rather than an asymptote there. And we'll see that in the next section as well. But I want to show you a few more, because you have to do some factoring in some of these. There's a few problems where the factoring is actually really hard, and we're not going to spend a ton of time on like difficult factoring like this one. You'll see here we have a number in front. Sometimes you can pull that number out, and it's not a big deal. This one, you can't pull out the 5 because 5 doesn't go in either of those two. If you know how to factor this, then by all means go ahead and do it. If you don't know how to factor this, then I'm okay for now if you just want to go ahead and hit C solution and skip it. There's not that many that are like this. But this one factor in with 5x plus 2 times x plus 8. If you don't know how to factor that, okay, again, if you skip that one, just ones where it has a number in front. Don't skip any other ones. Most of them you should be able to factor. This one you're just going to solve for x. You get x equals negative 9 over 15. So reduce that negative 3 over 5. And then again, you just need to plug it in here and make sure you don't get 0. I'm going to show you a couple more. There are some factoring ones, I believe. Alright, so here's a little bit different one. This one you could solve the same way. Still going to set the denominator equal to 0. 2x squared minus 18 equals 0. And solve it, so you're going to add your 18 over. Divide by 2. X squared is 9. Get the square root. X is plus and minus 3. Okay, then you have to check both of these in here and make sure you don't get 0. So on this one, let's see. I think you'd be good. 45 minus. Yeah, I'm pretty sure you'd be fine with both of those. But you do have to plug this in. Just double check you don't get a 0. I'm going to show you one where you actually do get 0. Let's see here's a different factoring one. How do we factor something like that? X squared minus 10x. Yeah.
Plus 5 and negative 5.
Oh, you're almost right. If this x weren't there, then I think that's what you're thinking, right? Plus 5. But actually, that would equate. We're gonna have to be minus 25. You're thinking the difference of squares, right? You're on the right track, though. Because we can't solve this, right? Yeah. So this you use factor by the GCF. If you see something in common with the terms, you just pull it out. So these both have an x. So we write x times x minus 10. Factor using the greatest common factor. If there's two terms and they both have x's, show that what you're going to do. So then we'll have x equals 0, x minus 10 equals 0. So this one's good. This one we would need to solve, we get x equals 10. And then we need to check them. So in this one we would get 0, it's going to be 54, so it's okay. When we plug in 10, you should be fine with that one as well, because you would get all positive, so it should be fine. There is some where you have to cancel them though. Let's see. So this would be another one that you could actually probably factor this one. It does have a 3 in front, so if you want to skip, you can. But what could you do first if you wanted to factor that one? Yeah, you could pull a 3 out, because 3 goes into all of these. So you pull out a 3, this becomes x squared minus 8x minus 9. And then the 3 you can kind of just ignore. You can then factor this, x minus 9, x plus 1. So then we get x equals 9 and x equals negative 1. And then actually when you check these, 9 is fine. But when you plug in 1, negative 1 squared plus 9 times negative 1 plus 8, you're going to get 0, because this would be 1 minus 9 plus 8. It's 0, so then you're going to X that one out and make 0 in the solution. So double check that. I'll be around to help you if you get stuck on the factoring. Kind of people are in different places on factoring, so I'll definitely help you if you're stuck on that. And you have the rest of the period to work on those. If you get those finished, I'll have a marble slides up here. It's on rational functions. It's kind of fun, and it should be challenging for you if you got that down pretty well. Right. Work on those. Raise your hand. Ask me if you need help. I'll be walking around. Go from there.